So this is section 2.3, biconditionals and definitions. So when we finish, we're going to be able to write biconditionals and recognize a good definition. So a biconditional is a single true statement that combines a true conditional and its true converse. So remember, a conditional is if P, then Q, and the converse is if Q, then P. So a biconditional is written by joining the two parts of each conditional with the phrase if and only if. So here we're going to write, we're going to look at the converse of this statement. If the sum of the measure of two angles is 180 degrees, then the two angles are supplementary. So the conditional statement is true. So let's write the converse statement. Go ahead and pause and let's see if we get the same thing. Okay, so when you wrote the converse, remember it's if Q then P. So if two angles are supplementary, then the sum of the measures of the two angles is 180 degrees. So now let's try to do the biconditional. So we're going to keep these two terms added and we're just going to add if and only if. So go ahead and pause and let's see if we get the same thing. So the biconditional is two angles are supplementary if and only if the sum of the measures of the two angles is 180 degrees. And we could write it as a biconditional because the conditional statement and the converse were both true. So a biconditional combines if P then Q, and then the converse, if Q then P. And notice these little double-sided arrows? That is the symbol you're going to use, and it's red, P if and only if Q. So on this example, a point is a midpoint if and only if it divides a segment into two congruent segments. So now they've given us a biconditional statement, and we want to write it as two conditional statements. So let's identify the hypothesis and the conclusion. So the hypothesis is a ray is an angle bisector, and the conclusion is a ray divides an angle into two congruent angles. So we're going to break it down. We're going to write if P then Q. So for if P, if a ray is an angle bisector, then it divides an angle into two congruent angles. So it's written if an angle is an angle bisector, then it divides an angle into two congruent angles. So now we're going to write if Q, then P. So if a ray divides an angle into two congruent angles, then it is an angle bisector. So we're just flipping the order. So once again, if a ray divides an angle into two congruent angles, then it is an angle bisector. So now we're going to talk about definitions and components of a good definition. So a good definition is a statement that can help you identify or classify an object. And there are three components of a good definition. Clearly understood terms. The second component is the definition, and the wording in it is precise. You want to stay away from words like large, sort of, almost. And the third component of a good definition is it's reversible. So you can write, and what I mean by reversible, you can write it as a true biconditional. So now we're going to write a definition as a biconditional statement. So the definition is a quadrilateral. A quadrilateral is a polygon with 4 sides. So how can I write that as a conditional statement? I can say if a figure is a quadrilateral, then it is a polygon with 4 sides. So if my conditional statement is if a figure is a quadrilateral, then it is a polygon with 4 sides, what's my converse? It's the opposite. So let's write that. So when we write the converse, we write if a figure is a polygon with 4 sides, then it is a quadrilateral. Now let's write the biconditional. So the biconditional statement would be a figure is a quadrilateral if and only if it is a polygon with 4 sides. So on this example, what we're going to be doing is we're going to see if any of these are a good definition. So the first one, a fish is an animal that swims. Well, it's not reversible because a whale swims, but a whale isn't a fish. So this one doesn't work. Now the next one is rectangles have 4 corners. So this one is not it, and it's because this is not a good definition because it's not clearly defined. Because all polygons have 4 corners. The next one, giraffes are animals with very long necks. So this one is not precise. It uses words like very. The next one is a penny is a coin worth 1 cent. This is reversible. A coin worth 1 cent is a penny. It's clearly defined, and it's very precise. So this is a good definition. And that's all for lesson 2.3.